Okay, so if variations in Earth's orbit are causing changes in temperature that lead in and out of ice ages, and global temperature varies with CO2 levels, then more accurately, you could say CO2 levels are varying with temperature, right? It seems like temperature is controlling CO2, which is true, right? But we understand now, through a discussion, a fairly rigorous discussion of the energy relationship that we share with outer space and the sun, right? We understand that we receive energy as visible light primarily, and then we emit energy as infrared radiation. And the greenhouse effect traps that at the Earth's surface and kind of recycles the energy before we let it kind of exit the system more slowly into outer space. So CO2 dictates temperature, but it seems like changes in temperature are driving changes in CO2. And so that's kind of perplexing. And it turns out that the truth is that both are true. CO2 does dictate global temperature, but if you change global temperature, right, just like we close the valve a little bit, or I guess more accurately, closing the valve and opening the valve on that little system that I have is like changing CO2 levels. Increasing the pump, the amount of water coming through the pump is like turning up the solar flux, right? Which it may not seem like we can turn up or down the solar flux, but in reality, that is what happens because the Earth's orbit gets either more circular or more elliptical, and the Earth, as a consequence, is further away from the sun during parts of its orbit, or the axial tilt changes, and the amount of sort of additional heating that we get during the summer months is less, or more. So changing the amount of energy and its distribution does drive changes in temperature. As a result, CO2 can respond through a number of feedbacks. And so we talked about a few of them. One is the shelf nutrient hypothesis, and that's just saying that as global temperature decreases, sea level falls because glaciers form. Okay, water's transferred from the ocean into continental ice sheets, and so sea level falls. When sea level falls, nutrient-rich sediments are exposed, and they weather very rapidly, and they deliver those nutrients back to the ocean. That delivery of nutrients stimulates photosynthetic production. Algae and aquatic plants grow, and then that biomass is transferred through the food chain, and some amount of it is locked up for longer timescales through a variety of processes that we'll explore in detail. But it is locked up, and that means it's not in the atmosphere. Okay, and so that means CO2 in the atmosphere is lower, right? So glaciers grow, sea level falls, and nutrient-rich sediments are exposed. Nutrient-rich sediments weather, stimulating productivity, which further decreases CO2, making it colder. Okay, this is a positive feedback, right? And it links temperature and CO2. Okay, if you change temperature, this this will happen, and CO2 levels will respond. Right. Similarly, you can fertilize the ocean through delivery of iron, because it turns out that iron is a really important micronutrient, and lots of regions of the global oceans are iron limited. So during more intense glacial times, conditions are generally more arid, they're drier, but also there are changes in the location and patterns of the trade winds in particular that increase the amount of dust blowing off of the Sahara Desert. It turns out, in modern climate, in the more recent past 100,000 years, million years, and so that is another positive feedback. Conditions get colder, and as a result, conditions get more arid. When that happens, and the trade winds intensify, when that happens, that wind blows dust off of the desert, into the ocean, which carries iron oxide, which is bioavailable, to the oceans and fertilizes them. And it stimulates productivity, which draws down CO2, making it drier and more arid, dustier, more iron, more photosynthesis, less CO2 in the atmosphere, right? So it's this another positive feedback linking CO2 and temperature. If you change temperature, CO2 will respond. Okay, there are a few others we went through. This one talks about carbonate platform weathering. If you lower sea level, these carbonate reefs that are growing, a few feet below the water surface, those will be exposed, and that limestone, calcium carbonate, weathers rapidly. Remember, we put acid on the limestone, and it fizzed, it bubbled vigorously. It reacts rapidly. And so that carbonate will weather, which does absorb, at least on short-term timescales, that absorbs CO2, and it'll lead to a further cooling, a further drawdown in CO2. So that's another positive feedback. Okay, one negative feedback we mentioned was terrestrial biomass. We said that as it gets warmer and glaciers disappear, that makes more land mass available for forests to grow. And that, in turn, draws down atmospheric CO2, making it colder, making ice sheets expand and creating less area for forests to grow, right? And so that is a negative feedback. It acts to buffer changes in the system. Okay, talked about a few others, but in general, there are lots of feedbacks that link CO2 and temperature. And so if you change one, the other responds. Whether or not you change temperature first or CO2 first, both will change in unison. Okay, and so we've been artificially increasing CO2 over the past couple hundred years through the combustion of fossil fuels, which has led to a global increase in temperature, right? They are inextricably linked through a number of feedbacks.